The search for extraterrestrial life is one of humanity's most profound quests. And now, NASA is set to intensify this pursuit with two ambitious missions aimed at exploring Mars and Europa, two celestial bodies that hold the potential for harboring life. Both missions were approved by NASA in December 2022 and will be fully funded in the next few years. Here's what we know so far about these groundbreaking endeavors. NASA's Dragonfly mission to Mars. The Dragonfly spacecraft is expected to launch in July 2027 from Cape Canaveral, Florida, aboard a SpaceX Falcon Heavy rocket. The spacecraft is designed to perform a series of flybys around Mars before entering orbit around the Red Planet. In August 2030, once in orbit, it will begin its mission to hunt for life. The main instrument on board the spacecraft is the Dragonfly mass spectrometer, which can detect organic molecules and isotopes. These are key indicators of biological activity. Dragonfly will also carry an ultraviolet spectrometer to identify minerals that form in the presence of water. This could help scientists understand whether or not liquid water has ever existed on Mars. In addition to these instruments, Dragonfly will have a camera and other equipment to study the planet's atmosphere and surface. Dragonfly will explore diverse environments across multiple locations on Mars. Its first stop will be the Moon's northwest region, where it will investigate organic-rich deposits and rocks that formed in a watery past. Next, Dragonfly will visit the Jezero crater, a 28-mile-wide area that was once home to a lake and river delta. Here, the spacecraft will search for signs of ancient aquatic life. After studying Jezero crater, Dragonfly will travel to the mysterious Noctis Labyrinthus, a vast network of canyons and mesas that may contain evidence of past volcanic activity. Finally, the spacecraft will end its mission at the Fornius Planum. It's a layered sedimentary deposit that could provide clues about the planet's climate and atmosphere. Throughout its travels, Dragonfly will make frequent stops at pre-selected landing sites to collect samples and conduct experiments. Each site was chosen based on its potential to yield new discoveries about Mars's history and habitability. As of February 2023, NASA has selected 9 potential landing sites for the Dragonfly mission. These range from ancient lakes and rivers to areas that may have once been habitable. Scientists believe that by studying these diverse locations, they can gain a better understanding of how life may have evolved on the Red Planet. After studying the Red Planet for about 2.5 years, the Dragonfly spacecraft will finally reach the end of its mission. As it runs out of fuel, the spacecraft will make one final descent to the surface of Mars, where it will crash land in the Utopia Planitia region. This region was chosen as the final resting place for Dragonfly because it is one of the most geologically diverse areas on Mars. By crashing land in Utopia Planitia, scientists hope to gain valuable insights into the planet's geology and history. Before crashing down, the spacecraft will take some final measurements and images of the surrounding landscape, providing an up-close look at the surface of Mars as it disintegrates into the planet. NASA's Europa Clipper mission. The Europa Clipper spacecraft is set to launch in October 2024 aboard a SpaceX Falcon Heavy rocket from Launch Complex 39A at NASA's Kennedy Space Center in Florida. The spacecraft is anticipated to arrive at Jupiter in April 2030 after a 6-year journey through space. It will then enter an initial orbit around the gas giant before beginning its mission to explore the Jovian moon Europa. Europa Clipper will perform a total of 45 close flybys of the moon over the course of its mission, with each flyby taking the spacecraft closer to the icy world than any previous mission. During these flybys, the spacecraft will use a combination of cameras, spectrometers, and other instruments to study Europa's surface and subsurface. One of the spacecraft's main instruments is the Europa Imaging System, or EYES, which consists of a camera and a spectrometer. Together, these instruments will allow scientists to map Europa's surface in high resolution and identify the composition of its ice shell. Another key instrument on board the spacecraft is the Mass Spectrometer and Plasma Dynamics Investigation, or MASPD. This instrument will analyze the gases and particles in Europa's thin atmosphere and the plasma environment around the moon. By studying these components, scientists hope to learn more about the moon's interaction with Jupiter's powerful magnetic field. In addition to these instruments, Europa Clipper will also carry several other scientific equipment to study Europa's geology, atmosphere, and magnetic environment. Over the course of its mission, Europa Clipper will explore various regions of the Moon, including its vast ice plains, its dark, mysterious cracks and ridges, and its unique linear structures, known as linea. During its explorations, the spacecraft will make several close passes over suspected warm water oceans that may exist beneath Europa's icy surface. By studying these areas, scientists hope to learn more about the Moon's potential for hosting life and its origins. Although Europa Clipper is not equipped to directly detect life on Europa, it will provide valuable data that can inform future missions. By studying the Moon's geology, atmosphere, and magnetic environment, the spacecraft will help scientists determine whether or not Europa is a suitable environment for life as we know it. If the data is positive, it will pave the way for future missions that can search for life on the Moon. One of the primary goals of the Europa Clipper mission is to determine the thickness and composition of Europa's ice shell by measuring the variations in the Moon's gravity and magnetic field. Scientists can estimate the size of the ice shell and the amount of water present beneath the surface. Additionally, Europa Clipper will measure the depth of the ocean beneath the ice shell and search for hydrothermal activity on the sea floor. These measurements will help scientists determine the Moon's potential for hosting life. Another important objective of the Europa Clipper mission is to identify the sources of organic molecules on Europa. Organic molecules are considered the building blocks of life, and their presence on Europa would provide strong evidence that the Moon could support. By analyzing the composition of Europa's surface and atmosphere, the spacecraft will help scientists determine whether or not these molecules are produced on the Moon, or if they originate from external sources such as Jupiter. The Europa Clipper mission is also expected to shed light on the origin and evolution of the Jovian system. By studying Europa and its interactions with Jupiter and its other moons, the spacecraft will provide valuable insights into the formation and development of the gas giant and its entourage of moons. This information will help scientists better understand the conditions that led to the formation of our solar system and the potential for life elsewhere in the universe. In conclusion, the Dragonfly mission to Mars and the Europa Clipper mission to Jupiter's moon, Europa represent exciting advancements in our quest to find life beyond Earth. With their advanced instruments and exploration plans, these spacecraft promise to revolutionize our understanding of the Red Planet and the Jovian system as we eagerly await their launch. We can be inspired by the audacious spirit of exploration that drives humanity to push the boundaries of the unknown and seek out answers to the profound questions about our place in the universe. What do you think about these missions? Leave your comments below, like and share the video. Subscribe for more updates on upcoming space missions and discoveries. Thank you for watching.